Thank you very much. Thank you very much. Yes, let's grab that for you, Jerome. There you go.
Oh, no. You can do that if you want, or you can play Clash of Clans. You can probably do that. You have done. You look at my ones. Yeah, it's gonna be like oh, I think
Mm-hmm. Leo, did you want to see your test? There you go. All right, my lovelies. We're actually going to go right now to page 69 because I feel like I assigned this earlier, but maybe some people have not done it. So let's make sure that we go through this because this is going to make the next page 70, 71 easier. If you've already done it, then guess you're ahead of the game. That's good. Now, I'm pretty sure that you guys can do number 1 and number 2. Yes? Rewriting the metric prefixes from largest to, ooh, this one's, yeah, from largest to smallest. Can you write the powers of 10? Right? We have mega, kilo, deci, centi, milli, micro, nano. Now, mega means 10 to the something, kilo means 10 to the something, and so do deci, centi, milli, micro, nano. See if you can remember them. There is another song that goes with this part. Mega, kilo, deci, centi, milli, micro, nano. 631,236. 9 is for the nano. Now, you are responsible for memorizing these. 631,236. 9 is for the nano. Now, the first two are positive. All the other ones are negative. Okay? So now what we're going to do is we're going to use that and we're going to say I have a centimeter. And I know that if I have mega, kilo, deci, centi, milli, micro, nano, centi means 1 times 10 to the negative. How much? Centi means 1 times 10 to the negative 2. Kilo means 1 times 10 to the positive 3. So what you're going to notice is that centi, you can just replace the part of the word that says centi. You'll notice we have 1 centimeter, or we have 1 times 10 to the negative 2 meters. You can replace centi with the power of 10. You can replace kilo with the power of 10. And what we're developing here is we are developing a whole bunch of things that are equal to each other. If two things are equal to each other, what can we make out of them? Something we learned about just in the last couple days. Conversion factors. These are all conversion factors. So if you know mega, kilo, deci, centi, milli, micro, nano, 631,236, 9 is for the nano, feel free to write this down, right? If you don't have them in your head yet, a mega, kilo, deci, centi, milli, like do that at the beginning of a quiz or a test, right? So that you have them right in front of you. And then you can always say, I know that 1 kiloliter is 1, and you can look it up and say times 10 to the 3 liters. I know that micro means 10 to the negative 6, so I can replace micro with 10 to the negative 6. Okay? And this is just practicing your abbreviations. This is just a little bit more. Now, down at the bottom, I'd like you to take a look at number 5. Is a kilogram many grams, or is a kilogram a fraction of a gram? Tell your partner, is a kilogram many grams, or is a kilogram a fraction of a gram?
Like asking when a kilogram is a fraction of a gram, or many grams.
So 1 kilogram, which is 10 to the 3. Do I need to take many grams and add them up to make a kilogram? Or do I need to take a gram and split it into many pieces to make a kilogram? What am I doing?
You're adding.
I'm adding them all up. You guys seem very uninterested in this, but this is where this particular exercise, I put this in here because people tend to put the power of 10 in the wrong place. And they'll end up doing things like this. They'll end up doing things like saying 10 to the 3 kilograms is equal to 1 gram. And if you know that a kilogram is many grams, now you're saying many grams is equal to 1 gram. And that makes no sense at all. So the reason for exercise 5 is to get you thinking. You don't want to say 10 to the negative 6 microliters is equal to 1 liter, because micro is a fraction, right? Micro is tiny. It's 10 to the negative 6. Microliters are small. So now you're saying I have a fraction of a liter is equal to 1 liter. And again, that makes no sense, which is why I would like you to start thinking about, is 1 kilogram many grams, or is 1 kilogram a fraction of a gram? Many or a fraction? Many. Microkelvin, is that many kelvins or a fraction of a Kelvin? Fraction. Fraction? Fraction. So you're going to do those ones as well. Okay, we're not going to spend time on it right this moment. You're going to go home and do that. Okay. 2.2b, we're going to do the first few together, because sometimes you actually don't even need to do a conversion. You don't need to use a conversion factor. If I give you a prefix, I call these ones prefix units. This is a prefix unit. Why do I call it a prefix unit? Because it has a prefix at the front. Yes? Prefix unit. This is a plain unit. Okay? So we have the prefix unit and we have a plain unit. If I give you some prefix units, you can turn them into plain units just by replacing. You can say, okay, I have 342.8, and I am going to replace nano with its power of 10. What is the power of 10 for nano? 10 to the negative 9. So I'm going to replace nano. I'm going to say I don't want to write nano anymore. I'm going to replace it with 10 to the negative 9. So I'm going to write times 10 to the negative 9. So 342.8 nanoseconds is equal to 342.8 times 10 to the negative 9 seconds. Did you follow that? Okay, all we're doing is we're replacing nano with times 10 to the negative 9. Now, what is wrong with this particular way of writing this? It is not in scientific notation. So that's why there's a second equal sign to allow you to put it into scientific notation. So you're going to take your decimal place and move it over 2 places. So you have 3.428. That number got smaller, so my power of 10 has to get bigger. This got smaller by 2 powers of 10, by 10 to the 2. So 10 to the negative 9 needs to get bigger by 2 powers of 10. So it was 10 to the negative 9. Now it becomes 10 to the negative 7. Let's do the next one together, and then you can try a couple on your own. 0.05 kiloliters equals, well, I'm gonna still write, because I want to just go to the plain unit. Remember, if I go from the prefix unit to the plain unit, I can just replace. So this would be 0.05. Now, instead of kilo, I'm going to write times 10 to the, what is kilo? Kilo is 10 to the 3. Yeah? So now I say, is that in scientific notation? What do you guys think? Scientific notation, yes or no? No. So we need to move our decimal place 1, 2 positions over. So we have 5. That part of the number got bigger by 2 powers of 10. So the 10 power of 10 has to get smaller by 2 powers of 10. We started with 10 to the 3. 2 powers of 10 less is 10 to the 1. Do you guys want to take a moment and do the rest of those? Okay. Yeah. Oh, when you look at that, you're going to write down negative coordinates and zero for now. Okay. And then you're going to write 6, 3, 1, 2, 3, 6, 9. Okay. Then you know which one is which. Because they match up. So write it down. Okay. Now you're at your target line. Yeah. Now, you say 2 is, yeah. Now you have to put it on. Yes. Yes, you know the sense of the sense. Yeah. If you finish that and you want to work on pages 55, 56, you can do that. Okay, what's that? Yeah. You may have done 54 yesterday already for homework. I know some people haven't, so I put it up there again. You know what I mean? It's always in practice, right? That way you go back and work plus with it. You got, yeah. Okay. Yep. Because nano is negative 9. Oh. Okay, thank you. Yeah. 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 Okay. Okay. Yeah. 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 Remember a little bit better. How's it going? Good. Right. Good. All right. Excellent. Oh, did you know 10 to the 6? Oh, my first 10 to negative 6. There you go. Okay. Yeah.
Well, actually, I do have an and 11:54 today.
11:54 today, yeah.
But a lot of
Yes.
It's a lot of stress. I bought
Okay, I just wanted to talk to you because you've now done a little bit of practice with that. We're looking at conversion factors. So, you know, this is on page 71, page 71. You know that 1 centimeter, hopefully you know by now that 1 centimeter is equal to 10 to the negative 2 meters, yes? Because centi means 10 to the negative 2. So you can write that as a conversion factor where you write the 1 centimeter on the top and the 10 to the negative 2 meters on the bottom. Or we can write the 10 to the negative 2 meters on the top and the 1 centimeter on the bottom. Either way is fine. So that is, she's not here. That is one way of writing metric conversion factors. Now, if you want to write 1 times 10 to the negative 2 instead, if you find that easier, you can do that. 1 times 10 to the negative 2 means centi. 1 times 10 to the negative 2 means centi. However, I don't want you to stop you from using conversion factors that you know and love because you've known them for years. Because if you just know that there are 100 centimeters in 1 meter, you can just use that. Yes? Either way is fine. Okay? So if you know if you know a common conversion factor, like 100 centimeters is 1 meter, you can use that. But for things like micro, where maybe you don't know it as well, you can say 1 micrometer is equal to 10 to the negative 6 meters. Is good? Okay, so you should be able to finish off this. So what you'll do for each of these questions is you will write, this is equal to that. You'll write one over the other, and then you will flip it over. Okay, so you will have 1, 2, 3 things for each question. Okay? So for our first one here, you would say 1 micromole is equal to what's micro? Micro is 10 to the negative 6 moles. So we have replaced the micro with 10 to the negative 6. You never want to have a power of 10 and a prefix in the same place because the power of 10 is replacing the prefix. Okay? So I never, ever, ever want to see 10 to the negative 6 micromoles is equal to 1 mole, because then you have your power of 10 and your prefix in the same place, and that is just 100% wrong. Once you've written it as an equation, you're going to write 1 micromole per 10 to the negative 6 moles. And then you're going to flip it over and write 10 to the negative 6 moles per 1 micromole. Okay, that's how those are going to go. All right. And I have, we got 10 minutes left. We're really pressed for time between now and spring break. I am desperate to finish this unit before spring break. So we're going to learn one more thing before you go home for the weekend, okay? Because you don't want to be like studying this unit over spring break. Do you? Yeah. No. No, you don't, because you're going to be studying the atoms over spring break. Tyler is going to introduce you. Wow. Our friend Tyler DeWitt is going to introduce you to the atom. So we are going back to page 57. 57. Okay. We have 5 kilometers per hour is equal to we don't know how many kilometers per minute. This is unusual, yes? Because we have stuff on the top and stuff on the bottom. So what we need to do is we still need to say at the start, I have kilometers, 5 kilometers per hour. At the end, I want to have kilometers per minute. Do I want to convert any of the top part? Or should I leave it alone? Do I want to convert any unit in the numerator? Do I want to convert kilometers into anything else? No, it's staying the same. So the only part I need to convert is in the denominator, okay? Can you think of a conversion factor between hours and minutes? Yes, I know you can. There are 60 minutes in 1 hour. Yes? So we're going to have 1 conversion factor in our calculation. So remember, our unknown is equal to our initial quantity times the conversion factor. In this question, who is the unknown? Kilometers per, it's literally the one with the question mark. Unknown, kilometers per minute. I don't know how many kilometers per minute. What are we starting with? We're starting with kilometers per hour. So that's our initial quantity, 5 kilometers per hour. And I know there's only one step because I know a conversion factor that goes between minutes and hours. Where do I need to put the hours in order to make them cancel out? I need to put them on the top. So this is where you need to say, where do I put things in order to cancel properly? So always be thinking that through. Don't just blindly write down 60 minutes per hour because you'll get the wrong answer. Okay? And we know there are 60 minutes in 1 hour. So 5 divided by 60 is 0.083. Repeater, the hours cancel out, and the units we are left with are kilometers on the top and minutes on the bottom. Yes? Is that good? Okay, we're going to do one more example, and then I'll send you home. If regular ground beef, this looks like an old problem as well, that seems very cheap. If regular ground beef costs $2.89 per pound, what is the cost in dollars per kilogram? Now, this is going to need a conversion factor between pounds and kilograms. I'm just going to tell you what it is today. I'll show you where to find it in your book next day, but we don't have time today. Rajan, could you shut the door for us, please? Thank you so much. What is our initial quantity in this question? Or actually, what's our unknown quantity? Unknown. What's our unknown quantity here? It is the cost in dollars per kilogram. So we need to find dollars per, do you guys know that per means divided by? Okay, per kilogram. What is our initial quantity? 2.89 dollars per pound. Now you'll notice, what have I done with this thing? I did not write it like this, $2.89 per pound. Can you think why I did not write it like that?
Pretty hard to cancel out.
It's pretty hard to cancel out. It looks like the pounds are on the numerator, right? Even though they're not, it becomes really hard to see what you should be canceling out. So make sure anytime you have this sort of slash thing, you rewrite it as 1 over the other, okay? No slashes, just 1 over the other. And our conversion factor, I'm going to give it to you. There are 2.2 pounds is equal to 1 kilogram. Okay? So our unknown is equal to the initial times the conversion factor. So we want to find the dollars per kilogram. Don't leave yet. So we have $2.89 per pound times, where do we need the pounds to go? We've got pounds on the bottom, so the pounds need to go on the top. That's a 6. So there are 2.2 pounds. Stop. Sit. £2.2 per 1 kilogram is good. Now you have dollars per kilogram. There's your homework. Have a wonderful weekend. Bye. Thank you for your patience. Yeah.